Shalom and welcome. In this video, we will be discussing the Pythagorean Theorem. The Pythagorean Theorem states that in any right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. Now, it did not say the sum of the legs. It says the sum of the squares of the legs. So if each of these legs form a square, which we'll be looking at more closely later. But I want to point out how to identify the legs. The right angle helps us identify the legs. The two legs form the right angle. And then the other side that is directly opposite to the right angle is away from it is the hypotenuse. Hypotenuse is the longest side, okay, of any right triangle. All right, here I try to draw this in GeoGebra, okay. A right triangle in the middle. See a right triangle here, and then we draw square. We draw a square on each of the sides, okay, and then find the area of each of those squares. That's what the Pythagorean theorem is saying. If we use out each of the side and draw a square, and then the area of the square of the two legs is going to equal the area of the hypotenuse. So hypotenuse is the longest side. Again, you see our right angle here. So this is the longer leg, the smaller leg. If you add up this area, 23.18, and this area, you're going to get this. All right, you're going to get the area of the area of the square on the hypotenuse. So, and if we try to drag, let me see if I drag this, move it around and change the number a little bit. Okay, you try it again, try them again, see the number changing area, change it, add them up again, you're going to get the area. Okay, you can pause the video and do that. And then if I move the one of the area of the hypotenuse, see all of them changing. Make it bigger, make it smaller, calculate it again, add up this area, the two small legs, area on the two small legs, you're going to get this. So that's what Pythagorean theorem is saying. And because area of a square is, because of the square, each of the side is equal. So this is side C, C, C. So you find the area, if you multiply C times C, that is C squared. So area of a square is, this square will be C squared. So that's why if we are given just one side of a square, we can just square that one side and get the area of the whole square, okay? So that's what the formula means. So that's where we have, since we can't always have the area, we are given just the side length. If we square that side length and square the side length of this one and add them and square the side length of the bigger one, they're going to equal, okay? But here is another way to look at it, just to visualize it. Cut each of those sides and try to fold it. I'm going to play this for you. Again, I created that in GeoGebra. Okay, play the animation. You see, just cut 2 points and then draw a right triangle. My big side, the second side, that's small, and then I try to cut the overlapping to fill the gap here. Then I cut this part, okay, and this part to fill this part. So you see the two small squares are going to fill up this larger square. Okay, that's what this is showing. Okay, another way to visualize it, the Pythagorean theorem. And I can drag this, move it around. You see this moving. So if I get, as the small one is getting smaller, the larger leg is getting bigger. And if I move it, I can just see, have it overlap, it all covers up. So those two areas are equal. Right now, let us use the Pythagorean theorem to solve problems. So if you're given a right triangle, let's start from a simpler one. Okay, identify the right angle. The two sides that form the right angle are your legs. So you square them and add them together. So x squared plus 10 squared would give us the square of the hypotenuse, 20 squared. Okay, I'm going to highlight this a little bit. Okay, so then simplify the numbers and then solve the equation. 10 squared is 100, and then 20 squared is my calculator, 20 times 20, okay, that's 400. Okay, and now we can solve the equation. Subtract 100 from both sides. I get x squared equals 300. And now, to get rid of the square, we need to take the square root of both sides. So square root crosses out square. So we have x equals the square root of 300. Now we need to simplify 300. Is it a perfect square? Oh, sorry. So if we simplify this, find a perfect square that can go into that. Of course, 100. So 100 times 3 would be 300. Therefore, we separate them. Square root of 100 times square root of 3. So x is going to be square root of 100 is 10. And then keep 3 under the radicand. Alright, so that's that one. And let's look at another one. Actually, when you're given a square root number, the same process, identify your right angle, then the two sides that form the right angle are your two legs. So set that up. So 6 squared plus x squared equals 6 square root of 2 squared. And how do we simplify this? Hold on. Okay, the side, anything squared, let's write it out here, is multiply itself twice. So you're going to be 6 square root of 2 is already 6 times square root of 2. So this is 6 times square root of 2 times 6 times square root of 2. So you're multiplying it twice. So this is 6 times 6, and then you multiply the square roots together. Okay, so 6 times 6 is 36. And then 2 times 2 is 4, square root of 4. And 4 is a perfect square, which is 2. So square root of 4 is 2. So if we multiply that, we get 72. Okay, so that's this side is going to be 72. So again, you can do that work in a corner. And then keep x squared, and 6 times 6 is 36. Now we can subtract 36 from both sides. So x squared will be left here, and this will give us 36 also. Wow, what do we find? Seems like this is so we take square root of both sides. X is going to be 36 is a perfect square, 6. So what that means, if x is 6 and this is 6, that means this must be an isosceles triangle. These two sides are equal. An isosceles right triangle. Okay. Right, here is another way you could be asked. They could ask you the question. Okay, this is not a right triangle. It is a trapezoid. But we can create a triangle out of it, a right triangle. So you need to kind of think outside the box and use your creativity and see how you can use what you have to get what we don't have. We are looking for x still. The whole of this length is 11. So, but if we create from here, okay, I'm using a dotted line, but because it's not part of the figure. So let's highlight this a little bit again. Okay. So if we do that, and then of course, since this is a rectangle, this side they gave you this, it means that each of these corner is going to be right angle. So here is going to be right angle also, okay, by perpendicular line. Now, since we know a a rectangle, both opposite sides are equal. So if this is 8, this is going to be 8 also. We write it in blue, it's additional. So this side is going to be 8 also. And if from here to here is 5, from here to here is 5, so what would be from here then to there? So if we subtract 11 minus 5, we'll get 6. So this side is 6. So, and we have all we need now to find x. This is a right triangle. Okay. So, and these are our two legs. So the 8 squared plus 6 squared would give us the x squared. 8 times 8 is 64. 6 times 6 is 36 equals x squared. And if we add them, let's see, if we go 64 plus 36 is 100. That's sweet. Because 100 is a perfect square. So once we get a perfect square, we don't have to worry about simplifying. So we take square root of both sides to get rid of the square. So they cross out anyway. So square root of 100, square root of 100 is 10 equals x. So how about this? Okay, get that.